So now we're ready to talk about the derivative of a quotient, the quotient rule, which is an incredibly shortened shortcut rule. And here I'll show the derivation of this, and in the next video I'll show some examples. So, from the definition of the derivative, the limit as x goes to 0 of, and then we get this gigantic expression, f of x plus h over g of x plus h, minus f of x over g of x, whole thing over h. And so the first thing I'm going to do is I'm going to just take the 1 over h and put it kind of out in front so that we don't have such a compound fraction. I'm going to find a common denominator. So the first fraction is going to get multiplied by g of x over g of x. So I'll get an f of x plus h times the g of x. The last fraction is going to get multiplied by g of x plus h. So I'm going to have an f of x, g of x plus h. And in the denominator, I have the common denominator now of g of x times g of x plus h. So now, again, what I'm going to do, as in the derivation of the product rule, I'm going to use this trick of adding and subtracting something in the middle. So we have the limit as h goes to 0. We still have the 1 over h out in front. We're now going to have this gigantic fraction. Of course, the denominator is still going to be g of x plus h. I'll have this piece, which is the f of x plus h, g of x. And then back here, I'll have a f of x, g of x plus h. And what I'm going to do is I'm going to subtract just the simple product, f of x, g of x, and then I'm going to add that product also, f of x, g of x. Okay, so it gets subtracted and added here, so it doesn't actually change the value. And let me underscore, what I'm showing here, of course, is the derivation of this formula. You will not have to do this every time. The point of this is to derive the quotient rule so you can just use the shortcut. And this is just where it comes from. So, now what I'm going to do is split this up into two fractions. So we have a limit. As x goes to 0, I'm going to have a 1 over h. I'm going to have this first fraction, which is f of x plus h, g of x, minus f of x, g of x. This is over g of x times g of x plus h. Then I'm going to have minus the second fraction. So again, we have to remember the 1 over h gets distributed. We still have the same denominator, g of x times g of x plus h. And then in this one, I'll have f of x, g of x plus h. That negative term becomes positive because of this minus sign, and the positive term becomes negative. So we have a minus f of x, g of x. Well, now you might be able to see where this is going. So in each one of these, I'm going to do some reconfiguring now. In the first one, I'm going to factor out a g of x. And then I'm going to move the 1 over h inside underneath this difference. So I get an f of x plus h minus an f of x over h, and this whole thing is over the double g expression. Then in the second fraction, very similar, I'll factor out the f of x. I get the difference, g of x plus h minus g of x. I'm going to put that over the h, that whole thing over the product of the g's. And then, of course, what we have is derivatives appearing. And so the final expression, we get an f prime of x times a g of x minus an f of x times a g prime of x over, and of course the g of x plus h in the denominator, that just goes to g of x. So we get g of x times g of x, which is g of x squared. And so this is the quotient rule.